Dear students, in the class we are going to discuss few problems in multiple integral. In the last class, I have given this example. Verify that both the integrals are same. So what are the integrals here? Integral over 1 to 2, integral over 0 to 1, x square plus y square dx dy equal to integral over 0 to 1, 1 to 2, x square plus y square dy dx. In particular, this problem says that even the order is changing here. It is dx, it is dy, and then see here first dy dx. That means here inner integration is with respect to x, outer integration is with respect to y. But here inner integration is with respect to y, outer integration is with respect to x. See the limits of the inner integration and outer integration. All the limits are constants. So all the limits are constants. For example, x is lies between that 0 to 1, y is lies between that 1 to 2. 1 less than or equal to y, less than or equal to 2. Okay, is it that? So here, when the limits are constants, just we can change the order. At the same time, you have to change that limits also. Okay, the answer also we have discussed in the last class. Okay, we solved that. First you have to take that LHS. From the LHS, just we are solving that, then we get the value 8 by 3. This is the LHS value. If you want a full solution of this problem, you can see that last class video lecture. Now we have to solve the RHS value. So what is the RHS here? Just we are changing that dx to dy, dy to dx. Then what is the solution here? Solution is 8 by 3. So already we have seen that previously LHS also 8 by 3, RHS also 8 by 3. Therefore, LHS equal to RHS. Just we are proving that the two double integrals are equal. So, very important note here. What is the important note here? From the above problem, we can note that the following fact. What is the fact we are getting here? If the limits of the integration double integral are constants, then the order of integration is immaterial. So order of integration is not the matter. So whatever the order we can write it, provided the relevant limits are taken for the concerned variables. And the integrand is continuous in the region of integration. This results output for the triple integral also. Even in the triple integral, in case the limits are the constant, you can change the limits. You change the limits. Next problem, you can see that in triple integral problem. Actually, it is the triple integral problem. We know this is the inner integration, dr is the inner integration, the d pi is the middle integration, and d theta is the outer integration. From this you can write that r is lies between that 0 to a, 0 less than or equal to r, less than or equal to a. So from here, second middle integrand is pi, pi lies between that 0 to pi, 0 less than or equal to pi, less than or equal to pi. And then theta, theta is varies from 0 to 2 pi, 0 less than or equal to theta, less than or equal to 2 pi. First we have to integrate with respect to r. Temporarily you can keep it that pi and theta as a constant. So the given integral we can write that the first integral is d theta, second integral is d pi, 0 to a r power 4 sin pi dr. First we have to integrate with respect to r. That means integral over what is the formula for x power n dx, that is equal to x power n plus 1 divided by n plus 1 plus c, is it not? So using this formula we can get that r power 5 by 5 from the limits 0 to a. So substituting that upper limit a here, a power 5 by 5, that you can take it outside, then remaining thing is 0 to 2 pi d theta, 0 to pi sin pi d pi, is it that? Next we have to integrate with respect to pi. In case if you are integrating with respect to pi, what is the integration value of sin theta or sin x dx? That is equal to minus cos x plus c. At the same time, in case if it is sin nx, means sin nx dx minus cos nx by n plus c. The coefficient should be come into the denominator. So what is the next step here? If you are integrating that sin pi, you will get that minus cos pi from that interval 0 to pi. So what is cos pi value? Cos pi value minus 1, and then cos 0 value plus 1, is it not? Generally cos n pi, what is cos n pi? Cos n pi is minus 1 whole power n is the formula. Okay, in case cos n pi, that means cos n pi equal to 1 if n is even. Cos n pi is minus 1 if n is odd, is a general formula. So cos pi 0 to pi d pi, if we are substituting that value, you will get that what is cos pi, taking that minus and then cos pi is there, then what you get here, cos pi minus cos 0, and then outside minus is there, so minus of minus 1 minus 1, that is equal to plus 2. Already 5 is there, therefore we are taking the 2 outside, so 2a power pi 0 to 2 pi d theta. Now simply you have to integrate with respect to theta, you will get that what is integration of 0 to 2 pi d theta, that is equal to theta from 0 to 2 pi. So you will get the 2 pi here. So therefore you have to multiply with the 2 pi, already 2 is there, 2 to 4, 4 pi a power pi by 5, is it not? So here I can write that how can you get that 4 by 5 pi a power pi, 2 by pi a power pi, what is this value? Just now we have calculated, it is 2 pi value. So 2 into 2, 4, 4 pi a power pi by 5, that is the integral value. Okay. Next problem is third example. Evaluate 0 to 1, 0 to square root of 1 plus y square dx dy divided by 1 plus x square plus y square. Here one interesting thing is there, how to draw that rough diagram for this. How to draw the rough diagram for this. Listen, what is inner integral? X. So the limit should be in terms of y or constant, is it that? So see that x equal to 0 and x equal to root of 1 plus y square. X lies between x equal to 0 and x equal to, what is the x limits? 0 less than or equal to x less than or equal to root of 1 plus y square. Y lies between the 0 to 1, 0 less than or equal to y less than or equal to 1. Then how to draw that the rough diagram for this? Take the x axis and y axis, it is x axis, sorry, it is x axis, it is y axis. Now what is given the shape here? X equal to 0 is a straight line, that means it is a y axis, is it not? And then it is y equal to 0, x axis is y equal to 0, but x equal to, in case x equal to root of 1 plus y square is there, squaring on both sides, what you get? X square equal to 1 plus y square. So x square minus y square equal to 1. It is like that x square by a square 1 minus y square by 1 equal to 1. So x square by a square minus y square by b square equal to 1, like that. Okay, so that means it is a hyperbola. Hyperbola, and then it is in that positive side. Is it that? So we can draw that hyperbola here. Both the sides hyperbola is there. Hyperbola, both the side is there. But one thing, it is starting from y equal to 0 to 1. So it is y equal to 0 here. Sorry, x equal to 0 to x equal to that 1. Is it that? Inside the inner integration is x. So draw the parallel line to x. Draw the parallel line to x. What is starting point? X equal to 0, and then the hyperbola, and then y equal to 0 to 1. In case y equal to 0 is here, y equal to 1 is here. Y equal to 1 here. So starting from x equal to 0, y equal to 1 here, y equal to 1. Therefore, this is the region of integration. This is the region of integration of this. How to evaluate it? Evaluation is the given integral 0 to 1, 0 to root of 1 plus y square, 1 divided by, it is in the format of x square plus a square format. When you are integrating with respect to x, keeping y as a constant. Keeping y as a constant. So integral over dx divided by x square plus a square formula is 1 by a tan inverse of x by a plus c. It is a formula. Okay, using that formula here, we can get that in the place of a, what is there? 1 plus y. Just you can imagine this 1 plus y as a. So a square plus x square is there. So we have to write that 1 by a in the place of a. Just you can imagine a equal to 1 plus y square. So, but sorry, a square is 1 plus y square. A is square root of 1 plus y square. So 1 by a tan inverse of x by root of 1 plus y square. See the limit here. In case if you are substituting x equal to square root of 1 plus y square, what is tan inverse of 1? Tan inverse of 1 is pi by 4, and then tan inverse of 0 is, what is the value? That is equal to 0. So if you are substituting that x equal to square root of 1 plus y square here we will get that tan inverse of 1. Tan inverse of 1 is pi by 4. So take it that outside. The remaining, that value is that pi by 4. We can take it outside. Remaining is 0 to 1 dy divided by root of 1 plus y square. Square root of 1 plus y square formula is integral over dy divided by root of 1 plus y square equal to log y plus root of 1 plus y square. In general, if you are writing that it is a square, dy divided by root of a square plus y square is log y plus root of a square plus y square, right? That is log y plus root of 1 plus y square. Substituting 0 to 1, what you get? Pi by 4 log 1 plus root 2. This is the solution of the problem. So from the given problem, you have to see that what are the things you have to first mention. What is the region of the integration? What is the region of the integration? And then you have to identify that what is the shape of that region. What is the shape of the region? And then you have to identify the region here. You have to identify the region here. So region is here. region is here. In case if they are not asking to draw that rough diagram, means no need to write that, but you should know that how to draw. Okay. Next problem. Example 4. Evaluate 0 to 1 x2 root x xy x plus y dx dy. So here we can see that what is the inner integration here? X. What is the limit here? X to root x. I want to write one note. In case inner integration in terms of inner integration variable is x, then the limit should be in terms of y. Limit should be in terms of y. Okay, but here the limits are in terms of x, is it not so? Therefore just we can interchange that. Question is not wrong. In case that question is given like that in the examination, you have to interchange that. Okay, most of the students are misunderstanding that that question is wrong, so they can left that. It is not like that. You have to change the order of the integration, then you can solve it. Then if you are changing that, what do you get? See here, very simply given that very important note. The limits of the inner integral are functions of x. The variable of inner integral should be y. Okay, so the I becomes I equal to 0 to 1 x to root x xy x plus y dy dx. Okay, so we can solve it. If you are integrating with respect to y first, then you are getting that value. Even I have solved this problem in the last class, maybe in the example. Okay, 3 by 56 is the answer for this. Please you try this. And then how to draw the rough diagram, I need to know that. Okay. Even I explained in the last class, once again I can explain here. So what is that y limit here? X less than or equal to y less than or equal to root x. What are the two shapes here? X equal to y and then x equal to y square. Is it not? It is a straight line and it is a parabola. Okay, how to draw this? Straight line is that 45-degree straight line. It is x equal to y and then x equal to y square. X equal to y square, it is like that. Parabola. It is x equal to y square. Is it not? Now, what is the inner integration axis? Y. Draw the parallel line to y axis. Draw the parallel line to y axis. So starting from x equal to y, that means straight line, ending with the parabola. So starting with the straight line, ending with the parabola, starting with the straight line, ending with the parabola. This is the region. Starting with the straight line, ending with the parabola. This is the region of the integration R. Okay, this is the way you have to identify that. Then how to find that this intersection point? Intersection point is 1, 1. This intersection point is 0, 0 origin. But how to identify this intersection point? That means this intersection of the straight line and parabola. Na? So x equal to y is there, and then x equal to y square is there. So if you are substituting x equal to y square here, you will get that y square equal to y, then y get cancel, then y equal to 1. Therefore, in case y equal to 1, x is also 1. So this is the intersection point. This is the way to identify the intersection point of any two shapes. Next problem is triple integral. Triple integral xyz dx dy dz. xyz dx, dy, dz. Inner integration is x. The limit should be in terms of either constant or in terms of y and z. The remaining two variables y and z. What is the middle integration here? Y. Y is the middle integration. The limit may be in that terms of constant or it may be the function of z. So it is correct order. It is in the correct order. The outer integration is z. That should be, the limit should be constant. It should not contain any variable. It should not contain any variable. Then you have to identify what is the region for this. You can draw the rough diagram. How you draw the rough diagram for this? What is given here? X equal to 0 to x equal to 1 minus y minus z. You take that y and z to that side, you will get that x plus y plus z equal to 1. So it is can be written as x by 1, y by 1 plus z by 1 equal to 1. What is the shape? It is tetrahedron with the intercept 1 1 1. Okay, that means you can draw the diagram here. It is x-axis, it is y-axis, it is z-axis. Equally take the intercept, equally take the intercept x, y, z. So we can join the points. We can join the points. Three points here. It is like the tetrahedron. So it is a region of integration. It is a region of integration. Okay. So if you are solving this, the solving part I can leave it to you. Then you can try that. Take the answer for this, and then finally you will get that. Okay. So what is the answer for this? Can give it your guess. Otherwise, I can give the final answer to you. It will take at least 5 minutes. What is the answer? Are you getting? Okay. That is the final answer is 1 by 720. Please verify this is the integral value. Okay. This is for your exercise. Thank you, students. See you in the next class with a different and interesting topic. Okay. Thank you.